And welcome to CSS in a components world. Okay, so before beginning, a little bit about myself. I've been developing front-end for a long time. I've joined Wix around 8 years ago. Wix was originally a Flash-based platform, and I came in to lead the move from Flash to HTML5. I'm passionate about developer tools, solving and layout and styling issues for the web, and I'm also the tired father of that 1.5-year-old energy bum who doesn't really care about any of this. So what are we going to talk about? We're going to talk about how we style today, from native CSS to the solutions we use to manage them, what's missing to style components, and what we have been up to solve these issues. So let's begin. How do we style? In the beginning, websites were beautiful. An ancient browser called Netscape Navigator introduced the idea of styling documents using a JavaScript API. Then we got presentational markup, like the font tag and the BG color attribute that allowed us to style our documents declaratively as part of our structure. And only later on, we got what we know today as inline styling, the style attribute. Notice that from the very beginning, styling was always accessible through JavaScript. CSS style sheets were introduced in HTML4. Style sheets give us separation of presentation and content. And by being outside of the markup, they provide greater flexibility than inline style, allowing us to reuse style definitions. Style sheets allow us to target specific elements using selectors like the class selector, attribute selectors, and others. They give us pseudo-classes and pseudo-elements to style the look and feel of native elements. Media queries to allow us to render our documents according to the state they are rendered in, if it's printing or mobile, and much, much more. And it is important to say that CSS is not only a syntax. It's a mature format with tooling and a rich ecosystem. It has wide IDE support, syntax highlighting, code completion, and so much more. And despite all of these features that make CSS easy to write, it is still hard to manage. It is hard to manage because everything is global. When we write in one style sheet, we can affect and conflict with others in our project. And when having multiple style sheets, the order in which we load them matters. It impacts the cascade. And although CSS has the @import rule, it is not a reasonable dependency system. I personally don't know anyone using it in production. And we said that style sheets give us separation of presentation and content, but it's a little bit misleading. Because although they are separate, CSS depends on the way we write our HTML markup. And when it breaks, we get no error and no validation. And it is hard to predict when something is not working. So we have the community to write other solutions. We have preprocessors like less and SAS that give us a build pipeline for CSS. Preprocessors add a CSS superset on top of our CSS, giving us scripting, logic, and sugar. They help us break down our style sheets into manageable chunks of code that reflects the structure of our project, and they assure the correct file order when building for production. But they don't solve the original issue of CSS being global. So we have CSS modules. CSS modules treats every style sheet as a module. Everything inside the style sheet is localized and namespaced, preventing it from affecting other style sheets. And CSS modules help us by mapping and exporting those definitions to our code so we can rebind them to our template. And finally, CSS in JS. In the last few years, we see a surge of solution implementations based on CSS in JS. According to our statistics, if you are a front-end developer, there is a 1 in 5 chance that you've already written a CSS in JS implementation. And we already said that styling was always accessible through JavaScript. So what changed? For example, in Wix, we have been generating CSS from JS since 2010, when we started the HTML editor, and our sites still do. We believe that the adoption of React and JSX reignited the interest in this concept, and it is important to say that CSS in JS is not a spec and not a single solution. The common solution solves namespacing and order of our CSS, but the big thing is that being dynamic is awesome. Look at those googly eyes following the mouse. This is possible using JavaScript. CSS alone is not enough, it is static. And it cannot be modified during runtime. CSS in JS makes it easy being dynamic. And it generates and manipulates CSS during runtime. But, as always, there's a cost. We need to load the JS and CSS JavaScript code into our runtime dependencies. We are creating and modifying CSS at runtime, causing the browser to reflow and repaint. And if we are doing server-side rendering, we are serving the same CSS twice, first as CSS and then as JavaScript. And the CSS community and CSS in JS community is aware of these issues and are working to solve them. Most libraries can output vanilla CSS from JavaScript, losing dynamic abilities. And some of the more advanced of them can extract only the static CSS, leaving minimal runtime to handle the dynamic parts. So, what do we believe we need in order to write CSS for components? We want to be able to break down our style sheets into manageable modules, reflecting our project structure. We want to be able to modify our style dynamically. We want to be fast and performant, with minimal runtime and caching where possible. We don't want to lose any of the CSS capabilities that CSS gives us. We want selectors, media queries, and everything else. And we want all the tooling that the rich CSS ecosystem offers. And finally, we want customizations. We want to separate the functional CSS of a component from any specific style. We want to be able to provide style from the outside, making it look as part of our project, making our style, our component style, more reusable. So let's see how we style HTML with CSS. There are many ways to style HTML using CSS. Let's see how we target an element specifically. So in this example, we have 3 nested divs. Each of them is marked with a CSS class, a gallery, a nav button, and an icon, a potential HTML markup for a gallery. Let's try styling that inner icon. We can use a CSS class for icon, and it seems to work, but it doesn't work always because we might have another CSS icon somewhere else in our structure. It's not unique to the nav button. So we make our selector a little bit more specific, adding the nav button class and making it work. But the same structure may appear in other places in our code, this time in a pagination structure. So we make our class selector a little bit more specific, adding the gallery class. And this seemed to work. But if our HTML structure looks a little bit different, it could be described instead of a nav button class with semantic elements, maybe a nav element with a nested anchor tag, basically replacing our nav button with semantic elements, or maybe with BEM convention. BEM stands for block element modifier. It's a convention that helps us create reusable components known as blocks. In our case, we have a gallery block with 2 inner elements, nav button and an icon. The icon is contained inside the nav button, and until now we talked about this structure as flat HTML, but now we can see a component structure. So we might look at it a little bit different and decide that our icon is a part of the button and not just contained by it. And we get this. Now our nav button is a block itself, a component, and our icon is a part of it and not a part of the gallery, a button icon, not a gallery icon. And if we look at our selector, we see that there are parts that are implementation details of our HTML. We only cared about the gallery nav button icon and the relationship between them. But let's put this aside for a moment and talk about how we target state. We can simplify our example looking only at the gallery and nav button, and we might want to hide our nav button while our gallery is loading. So how can we express such a state? We might use a CSS class like loading on our gallery, or maybe a data attribute, or again, maybe a BEM convention. And like with our example before, we have implementation detail in our selector. And we only cared that when the gallery is loading, the nav button inner element is targeted. And when removing those implementation details, we are left with missing information. What is the relationship between these parts? The gallery class is a CSS class that should represent a gallery component. Loading should be a state of the gallery component, and nav button should be an internal part. So what can we take from native syntax to bridge that gap? We can use pseudo elements to show that our nav button is an internal part of the gallery component, and pseudo classes to indicate that the gallery is loading. And when adding those pseudo selectors, we reconcile the missing information about those relationships, and we are left with the resulting selectors. We still have the big question of what gives the gallery class the traits of a gallery component. What tells the CSS that we want to target our gallery when it's loading, and we want to target an inner nav button. This looks like a valid selector, and it seems to say what we want it to say, but it doesn't work. It's not CSS. So how can we make it work? A possible solution would be to introduce an interface to our style sheets. Such an interface would enable us to describe relationships and definitions for inner parts and states of our style sheets. And this is starting to sound a little bit like a type system. So what the hell? No. Let's talk about typed CSS. Typed CSS gives us a CSS superset with syntax describing internal parts and states with their implementation, and allows us to export and import them in style sheets so we can reuse them. With static analysis, we can recognize such a syntax and provide IDE and build support, giving us code completions, validation, and highlighting for our style sheets. And by being in the build pipeline, we can identify CSS definitions that are not used and remove them. And we call this rule set shaking. It's a little bit like tree shaking, but for CSS. And with that in mind, I would like to show you a project we've been working on, Stylable, a typed CSS implementation. Stylable is a CSS preprocessor for styling components with typed CSS. It's the result of multiple POCs revolving around styling components spanning several years. We believe it sticks to the spirit of CSS, and we've discussed features we've extended or added with members of the CSS working group. If we go back to our gallery example, our selector that we wanted to express, let's see how Stylable makes this gallery class a gallery component. So first of all, Stylable uses the stcss file name suffix to define stylable style sheets. In our case, we are looking at the page style sheet, page stcss, and Stylable aims at having a CSS-compatible syntax so we can work with any CSS tool out there. We define a normal CSS class for our gallery, the gallery class, and let's make our gallery class a gallery component. For that, Stylable provides us with Stylable import tool. We can import the definition of our gallery style sheet into our page style sheet, and we can use the stExtend rule in order to tell that gallery extends the gallery definition, making the gallery class a gallery component, and giving us access to the gallery component style API. Now we can express the selectors we wanted to express before. We can say that our nav button is hidden while our gallery is loading, or maybe that we want to style the inner icon of a navigation button of our gallery. Let's look at how our gallery, the gallery style sheet, define those inner state and elements. First of all, Stylable offers the root class. The root class is reserved for the root element of our component, And we can define custom state with stylable stStates declaration. It allows us to define custom pseudoclasses. And it can accept multiple values. In our case, 2 of them, loading, to show that our gallery is in loading mode, and empty, to indicate that our gallery has no content. This does not set the state, only exposes possible states for our selectors to target. Let's see how we define the nav button. So any CSS class defined within a stylable style sheet is accessible as a pseudo element, a custom pseudo element. But it is still targeting a universal selector. We don't know, it doesn't have any specific interface, the nav button. So like we did with our gallery, we can import an icon button, for instance, and use the stExtends to say that our nav button extends that icon button. So just a quick recap of what we just said. stCSS file name is used to define stylable style sheets. We are trying to be compatible with CSS so we can work with any tools out there. We have an import rule in order to allow us to bring definitions from other CSS and JavaScript files into our style sheets and use them. We can extend with stExtend a CSS class and tell it that it inherits from another style definition. We have custom pseudo elements and classes that we can expose and abstract our inner implementation with. And with that, we have a basic understanding of how stylable is used. So what is the state of stylable? First of all, it's open now on GitHub, open sourced. And we are currently battle testing it with Wix's back offices applications. And we're evaluating how to integrate it into Wix websites. It is not yet a full or final implementation, but it features all of the concept we've been talking until now. And a number of other features we just didn't have time to go into, like more feature of the dependency system, the theming mechanism, variables, mixins, and others. We have a VS Code extension that provides code intelligence with completions and validations, and integrations with Webpack and React. And what's ahead? We have some features that are more for developers that consume UI libraries, and others for developers that make them. For instance, we have custom pseudo classes with parameters. Previously, we saw a gallery with a loading state. It could be loading or loaded. But sometimes we want to target an element according to a state that is not a Boolean. In native CSS, we can utilize nth child, allowing us to target specific elements based on its containment order. And we can offer similar custom capabilities, allowing us to target our DOM more specifically and not just by a true or false value. Formatters, we want to give you the ability to have custom functions for your CSS declarations. For example, if you would like to change a specific shade of a color into a darker one. We know these features exist in other solutions as well, and we want to be compatible with them. And we want to allow you to define your own declaration interface. If we go back to our gallery example, gallery allowed us to have access to an internal part, the nav button, a custom pseudo element. Our gallery might want to allow us to style the way our nav button looks, but it might want to restrict us from changing its position. So we want to allow that. Future compatibility. Currently, web components have no way of styling through CSS. There have been several deprecated specs trying to achieve that, and the latest draft is for double-part and double-theme, and if it will be implemented, we could support it as well. We want to give more integrations for IDEs, build tools, and libraries, and if we are looking at type system, we are starting to see our styling system as a type system. And there are many things we can borrow from that domain. And it ties us to one last thing. If you are not familiar with TypeScript, TypeScript is a superset of JavaScript that compiles down to plain JavaScript. With static analysis, it gives us completions, validations, and highlighting, giving us better developer experience. And the TypeScript community maintains a project called Definitely Typed. Definitely Typed gives us many type interfaces for non-typed projects out there. And giving TypeScript developer the similar experience when working with those projects. And we believe that with Definitely Styled, we have a similar opportunity to provide better styling tools and capabilities for existing component libraries and HTML projects today. And with that, I would like to go into a small demo. I don't believe in any demo gods, but I do trust Murphy. So I've embedded the demo in the presentation. If you haven't noticed, this presentation is based on Reveal.js. Reveal.js is an open source presentation framework that is based on HTML, CSS, and JavaScript. And I've created a small stylable interface for Reveal.js. And this presentation is styled using that interface. So any CSS rules you'll see in the next slides is implemented in the presentation and is just applied during the slides. It's not mock design. So first of all, we can import the Reveal interface just like we imported the gallery or the icon button before. And this time, instead of extending it, giving a class the ability to be with a specific interface, we use it like we use a normal tag selector in HTML, in a CSS, targeting an HTML element. We get completions for what Reveal.js has to offer and the interface I wrote. We can target the navigate button, which is the arrows on the right side, at the top corner of the screen. And we can modify their colors. We can target the progress bar, which is the lower blue line at the bottom of the screen. I've increased its height to make it a little bit more noticeable and colored it red. And since we are towards the end of the presentation, the progress bar is small, and we can color in the internal bar as well. It indicates the time that already passed. So if we target it, we can see that we can chain pseudo elements together now, giving us a way to change the presentation. Now, this is just the interface that I created for Reveal.js. It's not a complete interface, it's just for the example here. But you can break an interface any way you want and target it. So with that, I would like to conclude my presentation. Thank you all for listening. Thanks for the organizer to put this up together, and to Bruce for being Bruce. I hope I made you think about styling and components in a slightly different light. The stylable docs are available at stylable.io. Stylable repo is on GitHub Wix Stylable. Please take a look, give us your input, help us bring CSS and components together. Slides are also available online, and I'll be sure to tweet the URL as well. You can talk to me. I'm Ido Rosenthal on Twitter, and I'll be at the Wix booth after this talk and for the rest of the day, probably. Thank you. Good night. Bye.